So this is a video to help us with the binomial probability distribution. And in order to be binomial, or a binomial probability distribution, you have to go through the following requirements with, every problem that you do. Identify it as binomial first, and then you can calculate with binomial. So the first requirement is that you have a fixed number of trials, and that fixed number is represented by lowercase n. You have independent trials. That means that one is not affecting another. You have two outcomes, success or failure. So S, capital S will be success, capital F is failure. So either success or failure, and success doesn't necessarily, represent a better outcome. It just represents the probability that you're trying to find. So like if my two outcomes are heads or tails with flipping a coin, and I want to determine probability of tails, success would be tails, failure would be heads. If I want to determine the probability of getting heads, then success would be heads and failure would be tails. So, success is not necessarily the better scenario. It's just the probability that you're looking for. And then the last requirement is that the probability of success is equal for all trials. So it stays constant. If this is my case, and probability of success is represented by small p, and probability of failure is the complement of that, so it's found by 1 minus p, and it's represented by lowercase q. Small p, probability of success, small q, probability of failure, and x represents the number of successes. Now, if you have these requirements met, then you can calculate the probability of this many x successes in n trials by using binomial case, which is the formula nx. And this is just combinations formula. I'll show you what I mean by that. P to the x, q to the n minus x. Or, if you've seen it this way, NCR, I keep putting R, NC, so P of x is NCX times P to the x times Q to the n minus x. If you're using your calculator, graphing calculator, then the little trick is binom PDF. And the order in which you input is NPX. So I'll probably use it with the formula and with the calculator. I'll show you, both. So let's assume that we have, let's say, a test with 10 questions, 10 multiple choice question tests. And you don't know anything on this test. You're guessing. You're randomly guessing on each question. Randomly guessing per question. So, because it's multiple choice, you have, let's say, 4 outcomes, 4 possible answers, meaning, A, B, C, or D. And, all right, let's see if, based on that alone, let's see if I have a binomial probability distribution case. So this is my abbreviation for binomial probability distribution. So if I have a 10 multiple choice question test, 10 questions, each one has 4 possible answers. I'm randomly guessing on each question. Let's see if I have these requirements met. Do I have a fixed number of trials? Well, yeah, I have 10 total questions. So my first requirement is met. I have a fixed number of trials. And in this case, that number of trials is 10. So n, small n, is represented by 10 in this case. The second requirement are, independent trials. So me guessing on one question, does it affect me randomly guessing on the next one? No, right? I'm randomly guessing. I'm just randomly picking A through D. So I have independent trials. The third requirement is 2 outcomes, success or failure. So do I have 2 outcomes? Well, yes, I have. I'm either going to get it right or wrong. So I'm going to define success in this case as the correct answer. And I'm going to define failure as the incorrect answer. And again, success is not necessarily the better outcome, and failure the, worst outcome, just we're going to end up determining probability of correct answer. So my success is correct, my failure is incorrect. And always define your success and failure before you continue, because the fourth requirement is the probability of success equal for each case. So small p. Well, the probability of success is equal for each case because p, small p, the probability of success. Well, success is defined as correct answer. The probability that I get the correct answer is 1 out of 4 because only 1 out of these 4 possible answers is correct. Therefore, the probability of failure, which is 1 minus p, is 3 out of 4, right? So I have 3 incorrect answers out of 4 total. So the probability of getting the correct answer, if I'm randomly choosing the answer per question, is 1/4, and it's the same for each question. And the probability of failure is 3/4 because I only have 4 choices. If there were, A, B, C, D, or E, then the probability of success would be 1/5, and the probability of failure would be 4/5. But I only have 4 outcomes, so 4 possible answers. So again, here we are. Now all 4 requirements are met, therefore binomial probability distribution is the situation, and I can use the methods that I have for binomial cases. So let's say that I want to find, now that it's binomial, the probability that I get exactly 4 correct answers, right? So I have 10 possible questions. So again, I'm going to write this. N was 10, small p was 1/4, and small q was 3/4. Now, I want the probability of getting exactly 4 correct out of the 10. That means because I defined success to be a correct answer, I want 4 successes in 10 trials. This is my x in my formula. So I have n, c, x times p to the x times q to the n minus x. I'm just plugging it into my formula. Now this is a little bit more complicated to do by hand than it is to do with the calculator. I'll show you by hand. This is a combinations formula. It says take 10 factorial and divide by 10 minus 4 factorial times 4 factorial. Then take 1/4 to the 4th and 3/4 to the 6th. So if I'm doing it by hand, this is 10 factorial over 6 factorial times 4 factorial. And I mean, I'm going to end up plugging this into a calculator anyway. So if I use the calculator trick, this is also the same thing as binom PDF. And again, remember that I told you guys the order in which I do that. NPX. So my total outcomes is 10. My probability of success is 1/4, comma. My x is, what was x? 4. Make sure you put the commas in. Binom PDF, if you are unfamiliar with where to look for it, it's in your calculator. You press second and then vars. And I could do a video showing you that also. But second, vars, this is also on TI 83 or 84. And when you do second vars, you just scroll down until you see binom PDF. And then you press enter. And then it'll ask you for the number of trials, P, and then X. And then it'll look like this after you press enter. So, try that out. It's located under second vars. When you do that, so let's do 10, comma, the comma's above the number 7 on your calculator, 1/4, and 4, we get approximately, I'm going to round to the nearest thousandth, 0.146, or in percentage form, 14.6%. Okay, so if I do this whole thing out and plug it into my calculator and get a decimal, I'll get the same thing as if I do binom PDF. Binom PDF is just a little bit faster, as you can see. Let's do another one. I'll keep this the same. I'll do a couple more. P was 1/4, Q was 3/4, right? And I want the probability of getting, let's just do 9 questions correct out of the 10. I want you to think about whether that probability would be high or low. I mean, if I'm randomly guessing on a 10-question test, the probability that I get 9 of them right should be very low. So let's see if I'm correct. So In this case, because I want 9 questions correct, these are my number of successes. That's my x in my formula. NCR or NCX, so 10C9 times P, which is 1/4 to the x, which is 9, times Q, which is 3/4 to the n minus x, 10 minus 9. So if you're using, the formula, a little bit more work, times 9 factorial, 1/4 to the 9th, 3/4 to the 1st, or the calculator, which is binomial PDF, NPX, this is 9. I'm going to round. So again, under second vars, go down to binomial PDF. N is 10, comma 1/4, comma 9. I get 2.861 E, which is times 10 to the -5th. So that little E in your calculator, it looks like this, 2.861 E -5. This is your calculator's way of telling you scientific notation. And if you have a negative value here, that tells you to move the decimal to the left 5 places. 2, 3, 4, 5. This is the value of this probability in decimal form. So we expected it to be low, because if I'm randomly guessing on 10 questions, it is very unlikely that I'm going to get 9 of the 10 correct, because I know nothing on this test. So the probability of that happening is extremely low. Let's say that I ask for the probability of, let's do at least 1 correct. Hopefully you guys know that the probability of at least 1 is 1 minus the probability that I get none correct, which is 1 minus P of 0. So I just have to find P of 0. And I'm going to use the calculator version, binomial, because it's faster, PDF. This is 0 successes in n trials, and I'm still dealing with 10 trials, and the probability of success is 1/4 and all that. So 10 trials, 1/4. This time I want 0 correct answers, because I want the probability of none correct here. Second vars, down to binomial PDF, 10, comma 1/4, comma 0, 0.056 rounded to the nearest thousandth. I get 0.944, or in percentage form, 94.4%, which looks like a very high probability. And I expect that. So I'm saying that on this 10 question test, where I have 4 possible answers, I'm randomly guessing on each one. The probability that I get at least 1 correct out of the 10, and that could be 1 correct or 2 correct or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10, the probability that I get at least 1 of them correct is 94.4%, which is likely. I'm sure if you guys have guessed on any test, it is likely that if you guess on all your questions, you probably will get at least 1 of them correct. That does not mean that you are passing the test. That means that maybe you got 1 correct, or maybe you got 2 correct, or whatever. So I expected this to be a high probability. I'll probably do one more really quick, dealing with these complements. What if I ask for the probability of getting more than 8 correct? Now this is out of a 10 question test. More than 8 means 9 or 10. So the or means addition. So I'm saying, well, if I want the probability of getting more than 8, not 8, more than 8, 9 or 10 questions correct, that's the same thing as finding the probability of getting exactly 9 correct plus the probability of getting exactly 10 correct. So I'd have to do, if I'm using the calculator, binomial PDF twice. So binomial PDF for this number of successes, 10, 1/4, 9, plus binomial PDF for this many successes, 10, I'm running out of space, 1/4, 10. If you're doing the formula, you'd have to do the formula twice, here and here, with 9 being number of successes and 10 being number of successes, which is why the calculator is much faster. And I would expect this to also, I'm going to do this on my calculator, I would expect this to also be a small value because, again, if you think about it, I'm going to this test, I'm randomly guessing on 10 questions, and, I'm saying the probability of getting, at least 8 of them correct. So 9 or 10 out of the 10 correct, that's passing, that's almost an A. Well, that's an A or above, actually, more than 8 correct. That's unlikely if I knew nothing on this test and I'm randomly guessing on every question. So I'll do each of these separately. So binomial PDF for 9 successes, 10, 1/4, 9. So if I round this, again, I think we did this before, 2.861 times 10 to the negative 5 plus, I expect 10 out of the 10 correct to be wrong. This one right here, this would represent 100% on this test. I expect that to be even smaller than this. 10, 1/4, 10. Yeah, so this is 9.537 times 10 to the negative 7. This is, almost 0. So if I add those together, 10, yeah, I am expecting this to be a very small probability because it's highly unlikely that I would go to a test and randomly guess on every problem and get at least 8 of them right, or more than 8 correct. 2.956 times 10 to the negative 5, which is 0.123429556. Very, very small. If I change it to percentage form, moving the decimal 2 places to the right, 0.02956%. This is a very, very unlikely scenario, and that is what I expected because I don't expect to go to a test, randomly guess on 10 questions, and expect to get an A or higher. Well, a 90 or above, which is basically an A or 100. So make sure the probability makes sense with the situation.